Okay, so on this question, they want us to find the distance between these 2 points. Let me first just show you the formula, how you get the answer, and then afterwards, I'll show you where the formula comes from and why it's actually true. But first, just let's go to business. How do we actually get it? Well, the distance formula between any 2 points goes like this. It's x1 minus x2 squared plus y1 minus y2 squared, like that. That's the distance between any 2 points. Now, why? Where's that formula come from? Do all that in a minute. But and maybe you don't care a lot, but maybe you do. Let's just crank it out for now. I know you do care about getting the answer, so let's do that first. So, couple parentheses, squared. Now, what goes in there? Well, as it says, x1, x2, what's that? Well, you come on up to the thing. This is x1, y1. That's the first point's x and y value. And this is the second point's x and y value, right? So that's what we mean by that. First point's x and y value, second point's x and y value. So I don't know if you can scribble those a little bit. Y1, y2, okay. Anyway, so now, and then watch out, there's subtraction symbols built right into the formula, huh? That's going to be in addition to whatever you plug in. So I'm going to plug in x1, that's minus 17. Take away x2, which is minus 18. Double negative there is going to become positive, huh? So watch out for that. Now, on the other case, y1, which is right here, 5. Take away y2, which is, again, negative 14. See the double negative action? So right here, we have negatives head to head and right here as well. So you know that's going to become positive, huh? That's going to be, just be a little careful there. Okay. So what's that going to become? That's going to become minus 17 plus 18 and 5 plus 14. See the double negative, positive, right? The negative from the formula and then the negative from the plugin, double negative. All right, and then let's crank this out. So then use your calculator. Minus 17 plus 18, that says 1. This is 19. And so now we're getting close. Square root of 1 plus, and then 19 squared. I'm trying to remember what that is. Is that 361? Yeah, 361. So then that's the square root of 362. And will they take the answer that way? I believe they will. They don't say whether they want a decimal or what they want on that one. Let me see. Yeah, take it. Yeah, they'll take a decimal or the square root. You can just type in the square root just like that, or you can hit the buttons on your calculator and give them a decimal. Either way, I'll show both. If the decimal, it's going to be 19.0263. You can get a decimal, or you can give them the square root. How would you simplify that square root? Like if you wanted to actually simplify it, do you know how to do that? So if you wanted to simplify that, you would need to break it down. It's 2 divided by 2. I know 2 goes in because it ends with a 2, right? Ends even. 2 times 181. But I think 181. I don't think that's going to break down. So it doesn't break down. So you can just leave it 3 square root of 3062, or you can type in 19.0263. It'll take it either way. So there's how we do it. Now let me give you the reason why. So there's the answer. That's all you need to do to get the answer. But let me give you the reason why. Like where's that come from? What did we actually just do? We actually took a couple of points and found the distance between them. Let me show you. Let me draw. I can the graph Where are these points? Back up and back down. Okay, so I'm going to draw an axis system and find these points. So this is the point minus 17, back 17, up 5. So back 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, there's minus 10. There's minus 5. Wait, minus 1, 2, 3, 4, 5, minus 5. There's minus 10, 11, 12, 13, 14. Minus 15, 16, 17. So there's a minus 17 up 5. So 1, 2, 3, 4, and there's 5. So it's right there. There's that first point. Minus 17 up 5. That's that first dot. Okay, and what's the second dot? Back 18, down 14. So that's back even one more. Back 18, down 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So back 18 down 14, those ones? Yeah, back 18 down 14. So that's way over here. You got that. So back 18 down 14. Okay, so there's that point. So what did we just find? We just found the distance. Well, it doesn't look very good, does it? No, it just keeps coming out like a straight line. So, I mean, it is, but I mean, without any slant. Got a little bit of slant. Okay, let me try one more time. Here we go. So that distance right there, that's what we just found. And we're saying that distance is 19.0263. That's the answer we just found, is the distance between those 2 points. It's 19.0263. That's what we're actually finding. Now, why does the distance, so this is all just theory if you're interested at all. Why does this formula even work? Why does that actually work? Well, it's because when you do this, when you have 2 points, let me do one more thing. When you have 2 points on an axis system, and you have some point over here, call it x1, some point over here, x2, some point up here, y1, some point up here, y2, right? You have the first point, x1, y1, second point, x here, I'll make them red, x2, y2, right? You have those 2 points then, and what you could do to find the distance, and this right here is the distance between them. Well, you can make a little right triangle out of it, you see? And this side right here is going to be x2 minus x1, isn't it? Right? Because it's how far out to x2, take away how far to x1. You see that? The horizontal separation between them. So say this is over 10 and this is over 6. Well, aren't they 4 apart? If one of them's over 10 and the other's over 6, then they're 4 apart. See, you just subtract the 2x values, you get how far apart the 2 points are horizontally. And then the same thing vertically, y2 minus y1. And that's a little right triangle. And so you can just do the Pythagorean theorem. I'm just telling you where they came up with the formula. I'm just showing you how they come up with these math formulas. They just did the Pythagorean theorem on the fact that this is some kind of point here, x1, y1, and this is some kind of point here, x2, y2, right? And they just said, well, the horizontal distance is x2 minus x1. The vertical distance is y2 minus y1. The actual distance is that diagonal line. And so they just said, oh, that's a right triangle. We can do a squared plus b squared is c squared, the Pythagorean theorem. The c is the distance. So this is distance squared. The other two, the a, the bottom, this is a, right? These guys right here is a, these guys is b, and this is c, in the a, b, c. So then they just said, oh, it's x2 minus x1 squared plus y2 minus y1 squared. And then they needed to turn that into regular distance, get rid of the square. So what does that? They rooted it, and there it is, the distance formula. That's why it's the square root of the difference of x values plus the difference of y values. There it is. That's the distance formula. So anyway, you might not care about all that. That's the theory. That's how they did it. All you have to do is use the distance formula which is the square root of the difference of x squared plus the difference of y squared, like that. There we go.